Hello, everybody, and welcome to another session of Me Programming Daily. This time, drakon render again. During this session, we'll be continuing what we finished during last session, which means this function. I would like to refactor it so that it returns not a single modified row, but a modified version of the input. So I'm prepared for this session not to end in completing this function, but at least we're going to experiment a little bit. So I hope you have a drink of your choice and you have a little minute to relax, wind down, and watch me write some Haskell. We know that this column index is probably not going to be used for much longer. So let's see how deep down the execution chain it goes. It goes to balance row. Balance row uses it to pass to this function. But for now, let's take it slow. I don't want to get too fast and lose the plot and the process. So this could be a little hard to debug and read, but stay with me, and I'm sure we can figure out if it's working or not. So my initial plan was for the balance row function to return not only the new row, but also an updated list of paths. Maybe not. This is just too much work. let's do this. So column slice is good. And we're going to return Let's not modify the input yet, just make sure that this is working. This should be a tuple. So I'm not expecting anything to change. The output should just be a little bit longer because, oh no, it shouldn't be longer. Yeah, because we're completely ignoring this. Okay, this is going to be okay. So this is just for the purpose of troubleshooting. We're going to return the same type as here, meaning a tuple consisting of the new row and new updated chart. And I'm going to borrow some of this code here. So that's the first part of the tuple. And the second part of the tuple is going to be new input. And this is just to make the code compile. We'll be fixing it later. And this is a tuple again. Now the output will be a little bit crazy. Where is this? 294. Oh, this is already an array. Oh, sorry, a list, I think. Is this what it says? And this one is empty. Because new input is always empty. Okay, perfect. This is what we want. Now, let's break this down. This is new row. Yeah, so let's delete this row because it just causes confusion. It was incorrect. Let's collapse all these for now. Sorry about that. Let's just narrow our nodes to these. So this should be one. Let's see. Okay, so what do we have here? No, this is not what we want. No, this is just confusing. I don't want this in my code. Let's restore the initial types where this just returns a row. We can have this function here. Yes, 1, 2. But even this is not correct. Okay, so this session will probably be only focused on correcting what we've done previously. So this is not correct. I was under the impression that it might, but it isn't. See, if you have, let's delete this. This is rubbish. If you have the new row represented like so, and this is again contraposed rows. It means that oh, I see what's happening. So this row is really two different values, and they need to be straightened out. Yeah, I'm not sure if adding that map was a good idea. Because without a map, everything seems to be perfectly readable to a human reader. But with a map, this is getting slightly confusing. Let's increase the limit to 3. And what we should see here is another row with nothing. With nothing because the balance row does not modify the input collection. Let's see if we do insert at. We don't do insert at. So let's see balance row. So let's see if slice actually produces an array, or sorry, a map. Yeah, it does produce a map. So that was a bad move. Okay, so let's try to, let's try to undo this damage. Okay, so let me explain. Slice produces a map, meaning that we, as we produce the map, we lose the information about which columns were in which path. So even though we do make a correct decision here, as icon present further down another path, we have no way of appending to certain paths if we need to inject valence points. So we need to undo that a little bit. So where is this column slice needed? So this is not correct. We should have a column slice, but we should also have this converted to a map. So slice is here. Let's bring it a bit closer. So I think we'll be correcting this now. We do not want to create a map. So slice map will work very similarly. To our slice, it will just accept different arguments. So the slice is a list of icons, and we need to return this. So we just do row. Sorry, this should be a column. And we can reduce it so it's not confusing. Let's call it an icon. And that will be just an icon. Oh, this could be much easier than I think. So here we don't need to check any of that. We just do data map insert. 289. Oh yeah, this is not defined yet. So slice, let's not touch. Colon slice, and in that case, just not to destroy this. We're going to pass a slice map here. Where is slice used right now? Here. So this is a column slice. And this needs to be a map. Because otherwise this fold R would not work. So here in the slice, we get rid of map. And we do this. Then ACC plus plus. I think this should work, and not map empty. With this. And if we flip the order of arguments, we can reduce this function. Finally, I hope this works. I thought is that better? So now functionally it should return the same thing. 1, 2, 0, that's a valent point. Then 3, and then 4. Let's see the limit. Limit is 3. Okay. But let's not forget the balance row is not returning what we think it should. The balance row should return an altered version of column slice. And what should get altered is the icons identified in this fold. So this ideally, and I think we're going to draw the line here today. This function should return a list of tuples. An icon, a new icon, and the previous icon. So something like this. And that way we'll know what is shifting. And this result will then have to be interpreted together with this column slice. But for now, the interpretation we'll leave for another session. For now, I'm just happy enough with this. So instead of this being a list of icons, let's make it a list of lists of tuples. And this will be a little bit tricky to interpret or troubleshoot, but that's fine. We'll correct everything. Now, the output is a little bit longer. So, tuple number 1 is changing into 1, or it's not changing. Tuple number 2, icon 2, or a row, or icon 2 in row 2 is not changing, so 2 is changing to 2. Yeah, I promised it would be hard to debug. So we need to probably think of something simpler, but for now it's good enough. 4 is changing into 0, aka a valence point. Perfect. So this 4 is this 4. We'll also have to change the order probably. Yes, but there's another element in that tuple, and that's 3. 3 is... Should it change or should it not change? It should not change. It should stay in place. So 3 is changing into 3. Yep. Now, the end of that row. And 4 is changing into 4. It's not changing. It's not moving. That's it. So, yeah, I forgot about the last step of the algorithm. And this is to apply the shifts into the original slice, which would look something like that. So we have 2 things to do. 1, apply the shifts to the original slice, or column slice. And 2, change the order in which icons are added to the map, if we can. And before we finish today, I would love to see how a slice of column identified by 2 looks like. 0, 1, 2. Is the slice 3, 4 or 4, 3? So here. Slice 2. If it's 3, 4, we're good. Well, are we? If it's 3, 4, it means that the process of making the column slice map is producing results out of order, and we should probably change it. Don't judge. Will this work? Or is it too crazy? Oh, sorry, I forgot this. I promised it would be difficult to troubleshoot. Row 2, we're expecting 2, 2, so nothing exciting there. But what we should see in row 3 is something that starts with the 3, but it doesn't. So the way we build the array, we build the map does not really depend on on the direction of the fold that we're implementing, but it's fine. We can keep using fold. So we can't change that. So this is a to-do for the next session. We need to go through the result of the column slice map and apply the results to the regular slice. Okay, I think that's good enough for now. Thank you very much for sticking with me, and I hope you have a great day, and I'll see you next time. Bye.